Hey everyone, today in this video we are going to solve one of the classical Leetcode problem, to sum using Rust. So let's dive in. So let us solve Leetcode problem 1, to sum. So we are given an array of integer nums and an integer target. We have to return the indices of the two numbers such that when they add up, it returns the target. So here we are given an array of integer and the target is 9. So if you see, if we add up 2 and 7, it will return 9. So we have to return the indices of the 2 and 7 respectively, which is 0 and 1. So we can solve this problem using a brute force approach by finding a pair of number which sums equals to target. We use nested loops to find the solution pair. So we start at 2 and check every combination if they add to 2 sums to 7. So we will check with the 2 plus 4, 6, that is not equal to 7. So we move next. 2 plus 1 equals to 3, that is not equal to 7. So we move again next. 2 plus 3 equals to 5, that is again not equal to 7. So we move to the next index, which is a 4. Now 4 plus 1 equals to 5, which is not the target. So we move next. 4 plus 3 equals to 7, which is the target. So we return the indexes of 4 and 3, which is 1 and 3. But there is a problem with this approach. The time complexity for this solution is big O of n square, which is not an optimal solution. Next, we will try to find the optimal solution of this problem using a hash map. So instead of checking every possible pair, we can actually make this way faster using a hash map. The idea is, as we look through the array, we will keep storing each number along with their indices in the hash map. For every new number, we will calculate its components and check whether that number is present in the hash map or not. If it is in the hash map, then we found the solution. And if it is not in the hash map, we will add the number along with the indices. So let's try to solve this problem. So first we are having 2. The complement of the 2, that is 7 minus 2, that is 5. Now we will check whether 5 is present in the hash map or not. 5 is not present in the hash map. So we will add the value 2 along with the indices 0. Next, we move to the 4. The complement of the 4 is 7 minus 4, that is 3. Now 3 is present in the hash map, 3 is not present in the hash map. So we will just add the number 4 with the index 1. Next, we will move to 1. Now the complement of the 1, that is 7 minus 1, that is 6. Now 6 is present in the hash map, not. So we will just store the value 1 with its index, that is 2. Next, we will move to 3. The complement of the 3 is 7 minus 3, that is 4. Now we will check in the hash map whether that is present or not. And we can see that the 4 is present over here. And the indexes of the 4 is 1. So we will return the indexes of the 4 along with the index of the number 3, that is 3 index. The time complexity for this solution is big O of n, which is much faster than the previous approach. So let's now dive into our code. So let us start with our coding part. At first, we will declare a mutable variable. Let's call it as a map. And we initialize that with a hash map. In Rust, to use a hash map, we need to import that from the standard library. So let us import that. We will use this map to store the index and the value of the nums vector once we iterate through the for loop. So next, we will start with the for loop. In the for loop, we will require the index and the value. For that, we will use the iter and the enumerate function in the nums vector to get the index and the value. Inside the for loop, first we will calculate the complement of the current index value. After that, we will check whether this complement value is present in the hash map or not. For that, we can use the if-let expression of Rust. So if the value is present in the map, we will just return the respective indexes. And if the value is not found in the map, we will just insert the value along with the indexes in the map. And at the end, we will just return an empty vector. Let us try to run this code now. As you can see, our code has successfully executed and it passes all the 3 test cases. Let us try to submit this code now. Now the runtime is 0 milliseconds, which is like very good. Thanks for watching, and if you like this video, please like and subscribe.